It's my third video in my module on discrete probability distributions, in which we're going to both construct probability distributions and graph them. So let's just kind of review a couple practice problems with the curveball on one of them. So let's go ahead and take a look at both of these examples. We say during the summer months, say a rental agency keeps track of the number of chainsaws it rents each day during a period of 90 days, because data is awesome to have. So they have their data here. We say the number of saws rented per day is represented by the variable x. So you'll notice here that our variable x represents the number of chainsaws we rent on a given day. So they say, well, I either rented 0 or 1 or 2 on a given day. There must never have been a day where they rented, say, 3 or 4 or anything else. So these are the only instances that they rented, either 0, 1, or 2 on a given day. So we've got these results. It looks like overwhelmingly they don't rent any chainsaws. 45 of the 90 days they didn't. But we say 30 of those 90, they've actually rented one, and then, half of 30, which is 15, they've rented 2 chainsaws. So what we want to do is create a probability distribution for this. The nice thing is we've already got our table kind of constructed where x represents the number of chainsaws we rented on a given day. So these are, these are the possible outcomes, essentially, is what our x represents. Possible outcomes, the things that could happen. My question is, how likely is it that they actually happen? So to find the likelihood, what we're going to do here is this. We're going to take each of these, which represent, let me write this up here, this is the frequency. We're going to add on a column here. We'll call this the probability of the given x. And in order to find the probability, what we'll do is this. We'll take the frequency of each category, and we'll divide by the total number n. This should give us the percentage of the overall that, consist of each possible thing that could happen. So for instance, what percentage of the days did we rent out 0 chainsaws? Well, we rented them out 45 of the 90 days. So we say, well, what would this be as a probability? If we type this into a calculator, we actually get 0.5. So we'd say its probability is a 0.5 probability of happening, or 50% chance of occurring. How about one chainsaw? Well, one chainsaw, we accomplished renting one of those 30 of the 90 days, which is 0.33. So this would be 0.33 repeating, 0.33. And then the last one here we say is 15 out of 90 for the last category, its probability. So this is a 1 in 6, and so that's approximately 0.166, okay? So this is about a point, say a 167, like 167 if we round it. So here are all of our probabilities. As a matter of fact, if you go through and add all these up, 0.50, if we add these up, we say like drag this over here, 0.5 plus 0.33 plus 0.167. Now, I had rounded these, but essentially they add up to approximately 1. These should all add up to totally 100% of our stuff. And of course, that's because if 0, 1, or 2 were all the possible things that could happen, and the probability of each of those things are listed here, then what we're doing is we're adding up all the probabilities of everything that could happen. Should be 100% of our stuff. So now we're going to create a probability graph of this probability distribution. So remember, we need to put our variables on here. We say we'll let our discrete random variable x be down here. We're actually going to call this the number of chainsaws rented on a given day. We say, well, we either rented 0, 1, or 2 chainsaws. We have 0, 1, or 2. On our y-axis here, we'll just go ahead and throw up our probability of each thing occurring. So now, when we're looking at this, you notice that the highest probability was 50%. We're going to do this in decimals this time. So we can actually don't have to go up to 100% on our y-axis here. We say dot, dot, dot. Let me stop hitting the stylus here. We're going to label this 0.5. Okay, so 0.5 is what we're going up to, and we must be going by tens if I've got 5 total notch marks. So all we're going to do is going to put our bars on here for each individual category. So for instance, what percentage of the time are we anticipating renting 0? Well, we said 50% of the time. So we're going to draw a bar here that goes up to 50% of the time. We say what percentage of the time do we rent one chainsaw? Well, 30 of the 90 times. So this is about 0.33. If we trace this out here, it'd be about that tall. And then we'd say, okay, well, 2 chainsaws was about 17% of the time, so that'd be about yay tall, which is about half as tall as this. So looking at this now, if I say, well, what conclusions could we draw? I would say, well, overwhelmingly, I expect not to rent a chainsaw. But if I'm going to be renting chainsaws at all, actually, I'm thinking that we're probably going to rent either 1 or none, okay? Not likely we're going to rent 2, and I can see this here because it has a small bar. Cool, okay. So let's try this one more time here. We say the probabilities that a patient will have 0, 1, 2, or 3 medical tests performed on entering a hospital are these respectively. Okay. When we say respectively, what we mean is this. If you had 0 tests run, that happened 6/15 of the time because 0 was listed first up here and 6/15 is listed first down here, whereas 3 medical tests goes with our 1 in 15 chance because they are listed last. So what I want to do is construct a probability distribution for the number of tests ran and then draw a graph for this. We're going to say let x equal the number of tests ran. And so what we get is this. We say, well, either xpx, I ran 0 tests, 1 test, 2 tests, or 3 tests. And actually, the nice thing about this one is we were actually hooked up with the probabilities. That is, we had a 6 and 15. Looks like we have a 5 and 13. 3 and 13. 15, sorry. 3 and 15, not 13. And then 1 in 15. So if we're going to graph these, you notice that these are listed in fractions, okay? So it's not that I'm worried about putting our stuff down here. We say number of tests. This axis is easy to label. We say 0, 1, 2, or 3. I just want us to be careful here when we label this axis up here, this p of x. We could do this in decimal, but it's a little bit cleaner to keep it is 15. So for instance, we could say 1, 2, 3, 4. And this would represent 5/15 right there, 6, 7, 8. And we'll just do this in fractions. So this 5/15 is this bar right here. So making this graph here, we say, well, 6/15 would be right here. So 6/15 of the time, we'd say a patient has 0 tests run. 5/15, a little bit less. We can see they had 1 test run. 2 tests run on a given time at the hospital is 3 out of 15, so 3/15 here. And then we also have 1/15 back here. So we say it's very unlikely to have 3 tests run. Actually, the majority of the time, you can see that you're either going to anticipate having either 0 or 1 tests done when you enter the hospital. So just a couple of examples.